changing software development at Google. Thank you very much.
Hello. Well, thank you so much for having me. It's great. My team at Google has started collaborating with Brian's team at Facebook, and I'm going to talk a little bit today about some of the things that we're doing together. I was excited to come talk at Scale because if I go back and think about the types of technical problems that I've loved to work on at Google, they have to do with scaling systems, whether it's in search or search quality or cluster management. And now with my team in developer infrastructure, I've always been curious and intrigued about how do we get something that is sort of falling over, scaling up to numbers that we can't even predict. So I started my career programming and have seen how businesses have had to adapt to rapid changing technology, right? If they don't adapt, they fail. So this complacency and not taking risks are something that really businesses have to keep up with. So, and the cloud is forcing, I think, companies to adapt their business at an even faster rate. They have to change, adapt, but they also get the benefit of using cloud technology. And working at Google, I have to say that change is the only constant. It's definitely how we continue to innovate in the space. So I think about what we do around sort of three assets. The first one is physical infrastructure, or our cloud. The second one is our code, or our products. And the third one is the people, right? The humans writing the software. So we have to think about the humans. So today I'm going to talk a little bit about the systems that enable engineers to do work at Google. I'm going to also talk about the systems that Google is bringing out into the cloud, just as other service providers, cloud service providers are doing. And then I'm going to talk a little bit about how we maintain our engineering culture. And a lot of this has to do with the tools that we bring into the engineering community. So innovation at Google. From search and ads and Gmail and Android, I heard some great announcements at the keynote this morning. Google's mission is very broad in scope. We're working on projects from self-driving cars to bringing infrastructure and access to users in remote areas of the world. And we have a high tolerance for failure and risk-taking. And this directly translates to the types of tools that engineers need to do their work, right? We believe in empowering teams so that they can make decisions and they can take risks and they can use experimentation and prototyping to test out and vet their ideas. So I believe we're able to innovate the way that we do at companies like Google and Facebook and many other companies in the industry because we can use cloud services now in new and interesting ways. And as developers, we're writing code and we're benefiting from the fact that cloud services, they're taking on a lot of the operations that maybe we had to juggle between writing code and performing those operational tasks. So for the past 15 plus years, we've been working on building the most reliable, efficient, physical infrastructure and software infrastructure built on top of that physical infrastructure so we can all benefit from it. But what is the cloud platform? I mean, today I'm going to talk a lot about Google because I work at Google, but we all know there are many other cloud providers out there. But really the cloud is about us at Google productionizing the things that we are using, tools, processes, systems that we've built all of our Google products on top of. And Google and developers are using those directly. So we're making it possible to use our infrastructure very efficiently and for anywhere from startups to enterprise companies to use our platform. So I want to talk a little bit about why the cloud is relevant and this idea of DevOps, right? So DevOps is this way of bringing developing your code and operating your service or code in the cloud closer together. And there's really interesting things you can do when you have this amazing feedback loop where you can observe your service running in production and you can feed the insights that you have back into your code. And you can automate away parts of the operations that you don't have to worry about. So the goal as a developer is that you have faster development, faster deployment, and ultimately more efficient operations. So let me talk a little bit about Google and scale. So again, I think part of the reason we're able to innovate is because we have this shared platform that we can all use and benefit from. But what's the scale that we're talking about? So each day at Google, over 18,000 plus engineers perform 800,000 builds, leading to 2 petabytes of output, over 100 million test cases run, and 45,000 commits. So these numbers may seem large, maybe not, but this is the type of scale that we're talking about, and that we want to bring those tools out into the engineering community. So before I move on, how many people in this room are developers? All right. How many tech leads, managers? Okay. How many people that work in ops, like site reliability or administration? Okay. How many people in here are happy with the tools that you use, the developer tools you use? Oh, brave people. All right. Well, I'm going to talk for the next couple of minutes about what we do internally at Google. And I think I just wanted to ask those questions because I think we all know that there's a huge opportunity in the developer tooling space to make us all more productive. And I asked for the tech lead manager point because I think managers and leadership should also really care about their developers' productivity and how happy their developers are with their tools, because that translates directly to delivering whatever you're trying to do for your user community. So I work on a team that's focused on developer infrastructure and tooling. We organize software development at Google. We try and make it fast, and we try and make it fun too. So from the time that engineers sit down to write code, to search it, to version it, to build and test and reliably release it, developer tooling is responsible for making engineers happy. And our goal is just to make developers' lives easier, so we can all, as developers, focus on code and do the things that we love. But it's not just about Google developers. It's about the entire engineering community. So that scale that I just talked about, Google's been operating these large-scale systems for many years, and we've developed some tools to operate, diagnose, and understand these services at a very large scale, almost absurd. And we've learned a lot of lessons, and so what we're doing now is we're trying to bring the lessons that we've learned and the tools that we've developed out into the engineering community. So we're taking the best of what we've built for Google and making it available to developers externally, but we're also taking the tools that engineers and developers are already using and already love and making them work well with our infrastructure. So how does Google build code? Well, Google's build system supports a variety of languages. It's really a recipe of how we build our software, and developers can express various relationships between libraries and binaries and get very fast feedback. But what does that look like under the hood? Well, it's massive parallelism. So build actions are farmed out to thousands of dedicated worker machines in our cloud. Again, this idea of backing a very fast software development process with cloud services. And we cache results across machines and users so that we have this transparent speed up for everyone when someone builds. So I've told this story before, but it's kind of one of my favorite stories to tell. When I joined my current team, I had been a user, and when I joined Google, I was really impressed with all the investment that had gone into developer tooling, because I was used to very long build and test and release cycles. And when I joined my current team, I got this really sweet, nice email from someone who had just joined Google and said, "Melody, I love the developer tools. The build is so fast. It's amazing. I'm so happy to be here." And I was like, "Yes, the team is awesome. We're going to make it better all the time." And then I was reading through what's one of our help threads for users to express problems. And this same engineer was like violently complaining about how slow the build was. So literally in like 2 to 3 months, their whole level of happiness had declined because they wanted things to be instantaneous. And I think that's the right expectation to have, right? So very few people raised their hands. I think a couple people in the front that they couldn't see all the people behind them that were not happy with their developer tools. I just think this is the way it is, right? If we keep making improvements, then the expectation and the bar keeps being raised, and I actually like that. So, why talk about, building code quickly? Why is that important? Well, when you can imagine that you have instantaneous feedback, right? Your velocity and your speed is just on a whole nother level. Okay, so how does Google test? Well, testing and developing safely go hand in hand. So we test the entire code base after every repo update, and this leads to consistency prior to releases. We have testing available before submit to identify breakages before they happen. And I think that's pretty cool, right? So we're proactively trying to make sure that people understand where they might be breaking other people's code. And we've developed a set of tools to bring real-time information to developers that are monitoring the build. They can easily identify failures and find culprit changes. And they can easily select from frequent green builds because we show all the testing results together. And we also integrate our testing tools with our release management tools. So again, we're trying to have that very fast build, test, and release cycle. In addition, we do a lot of automated web testing and mobile testing, millions of test cases a day over 20 plus some odd OS and browser combinations. So again, why care about good testing and automated testing? Well, I think when developers don't have to worry about testing, they're more likely to experiment, to break things, and to know that they're safe. To know that the dev tools and the engineering systems are really making sure that quality code is going out the door. So what does Google do internally to manage our code? Well, we do have a single monolithic tree with very fast access for developers. And that means development on one branch with submissions ahead. We integrate early and often, and developers can view, modify, and experiment with code across the repo. And I think this is really important because it's a level of unparalleled sort of access that is sort of transmitted through our entire culture. And we all know developers love languages. So C++, anyone? No C++ program? Okay. So yeah, we support C++ and Java and Go and Python and a variety of other languages. So developers can use what they're good at. And I just wanted to mention Rachel Potvin, who is here, is going to be talking in detail about Google's code management later on today. So definitely go to that talk. But what does that mean for engineers? Well, when you have a single tree, you can do very interesting things like globally analyze and refactor code. So think about wanting to make a global API change, right? We have the ability and tooling to support it to be able to look for all references to that API change, generate change lists, send those change lists out, and then flow those changes through our release process. And with hundreds of millions of lines of code, keeping the code base clean is important. When you have fast access, engineers don't hesitate to sort of ask and answer questions about a particular API or library. And when you merge early and often, you have this ability to easily roll back when something breaks. When our code base is open, more likely to maybe help fix another developer's bug and have that level of collaboration. And we also require mandatory code reviews. Quality is important, and it's also a great way to learn, right, to go through the code review process. So what's it like to be a Google engineer? We've heard a little bit about some of the systems that we use to write the code that we do, but what about the people? So, working on problems at this level of speed and scale can be quite a challenge. And as I said before, engineers sort of keep raising the bar on what they expect. So internally, collaboration and code development, it's really a key part of our culture. And we have this accountability of helping to fix each other's issues. Now, I think it doesn't come without its own challenges, which I'll talk about in a sec, but it is this idea of working well within a team to collaborate and do that type of development. The level of sharing code across the company and having this common infrastructure, both the physical and software cloud services and platform that we have, means that developers don't have to write code. They can look for something that has already been written and use that instead. And developers want autonomy, right? We want choices to use the things that make us productive and not have something forced on us. So I'm going to do the IDE question. So you ready? Everyone ready? Okay. Okay, Eclipse. No one. Okay, I'm supposed to be asking Adam, right? Is that what Facebook use? I'm asking Eclipse users, IntelliJ users, any Vehement IDE users, Emacs. See, there you go. VI. Yeah, see, there we go. So to force developers to use something that they don't find productive, it just doesn't work. So we support a variety of options internally. And the final one here is that we, sometimes this is a challenge, but we do use things before we put them out to our user community. So we have this idea of dogfooding. So, over the years, I've witnessed a variety of things across many different areas of Google. But the one thing that I wanted to talk about is really that staying close to our users is sort of paramount. So, yes, we may try ideas, and yes, they may fail, and we learn from them, and we conduct post-mortem so that we feed that into the next project. But I see us every day demoing, sometimes very early stage work to our users to see if our ideas are headed down the right track. And that is consistent. I've seen engineering teams do that across the board. So all of that sounds great, right? Fast developer tools, great testing, great build. But we definitely have our challenges. And there's a couple folks from my team here, and some of the emails and maybe constructive suggestions we get about how to improve our developer tools are interesting, but there's this idea that it's never fast enough, right? No matter how much we invest in performance and reliability, I think developers expect instantaneous feedback, and we should give that to all of us, really. Keeping up with change when you have the velocity that I talked about, it's tough, right? There's dependencies that maybe we didn't find before we started to do a release, and there's breakages, and sometimes it's really hard to keep up with that. Our quality processes, very important, but sometimes they slow us down. And so we're constantly looking for places where engineers are frustrated that some part of the process is a barrier or kind of a checkbox that's holding back their code from being pushed out the door. And we have a lot more work to do in that area. And finding and fixing bugs is tough, right? And I think this is one part where I see cloud services really changing things, because we're understanding through monitoring and auditing and debugging and alerting how to think about the debug and fix cycle in a new way and reclaim that time for developers. So although we set out to sort of build this for ourselves, we're now offering it up in the marketplace, cloud services. And so whether you're a startup or you're an enterprise developer, you can get all of the benefit of this massive compute power. And it's pretty amazing to see how quickly cloud compute is available now in the market. It's basically become a commodity in terms of pricing. And we want, we, like other cloud providers, want companies to benefit from that. So what does that mean for us as developers? Well, it means we get to focus on our core mission, right? Which is the ideas, the innovation, the code, the next product, the next app that we're going to build. So Google Cloud Platform has a broad set of services from compute to storage, networking, and developer tools. And I could spend hours talking about them, but this is not about Google's Cloud Platform. I want to focus on developer tools because I think there's some interesting things that we're doing there. When I joined the team, I was really interested in the scaling problems that we had set out to solve. But the other thing that I was really excited about was this idea that we could take the internal development tools and bring them out into the engineering community. And so that's what we're doing. I think, again, sort of we've learned some lessons at this type of scaling challenges that we've had, and we want to bring that externally. So I'm just going to talk a little bit about the tools that are available on the cloud platform. So as developers, we're mainly oriented around the language that we care about, right? So we pick the language for the thing that we're going to develop, and we want a great tool set that goes with that. So just as we have this internally at Google, we're making sure that our cloud platform supports that. So things like getting started, you can see the IDEs, great release and deployment, so that it's really easy to get up and running. But the thing that I want to focus on is this last bullet point, this cloud diagnostic insight, because it comes back to this idea of DevOps, right? This feedback cycle between operating your service and making your code better. So if you look at any studies out there, you can find a whole range of quotes, but some of them say over 50% of our time as developers is spent debugging and trying to diagnose problems. And most of the time, well, some of the time, it can be a very high stakes, time critical situation, right? And you're having to comb through lots of data. And you know, the problem could be anywhere. So what I think as developers we should expect are great tools to give us insight into the service to try and reclaim some of that time that we're spending. So the first tool I wanted to highlight was something that we launched called the Cloud Debugger. I think some of the challenges with debugging tools is that a lot of them are not integrated. So when you get an alert or your pager goes off, you need to start figuring things out. You need to look at logs. You need to go look at what the alert was. Maybe you need to add some more logging. Maybe you need to re-release. But there's this cycle that can consume a lot of time. And really what you want to do is you want to find the source of the issue and you want to fix it and you want to get that release out as quickly as possible. So the Cloud Debugger is something where you can, within the code, set a watch point to take a snapshot and basically let the service run, and then you can drill into and examine the stack and look at all the variables. You don't have to add more logging statements. You don't have to stop the service. But it really is this way to observe what's happening as your application is running in the cloud, find out what's going wrong, and then as quickly as you can, right, feed that back into the code and make the fix that you need to do. So again, I think this is an example actually of us working on something and then trying to find new ways to integrate it into the larger tool set at Google. The second thing I wanted to talk about was Cloud Trace. So this is an example of something that we do internally and bringing that out into the community, where you can visualize where time is being spent in your application. So say you get a complaint from some of your users that they're experiencing slowness. You can dig into your application and look for areas where latency is high. And you can do things that I think are sort of interesting by going back and looking at multiple releases where maybe there was a pattern of degradation and start to use that to make improvements to how your app is running in the cloud. So I know I talked about how Google manages our internal source. And while we use a monolithic repository externally, we need to meet developers where they are, right? Again, this idea of choice. So we host private Git repos for each cloud project. You can easily sync your code from GitHub or Bitbucket, and then you get all the value of the debugger and the trace and all the features that we're offering on the platform. So I talked about testing and that we do web app and mobile testing. We're in the process of launching something called Google Cloud Test Lab, which is really mobile test as a service. The ability to test on mobile apps it's really challenging. Even mobile development is challenging, I think you can say that safely. But what we're launching is both physical and virtual device testing for Android, and we think there's a real opportunity to help improve the quality of applications, of mobile applications out there. By offering things like robot testing. There isn't a whole lot of testing happening because it's difficult. So we think there's some easy things that we can do and offer for developers. Again, building on the experience that we have internally within Google. So that's a little bit about cloud. I also want to talk about the fact that we're starting to open source some things that we've developed internally. So when I talked about the build system, I think we really believe in this idea of bringing dev tools out into the community for everyone. So I'm really excited about Bazel, which is the open sourcing of Google's build system. We just announced our beta launch, so that's pretty exciting. And on the more to come point, there's two projects that I wanted to highlight, Kite and ShipShape, which are in early stages. ShipShape is a way to create an ecosystem around program analysis tools. So the analysis writers focus on the analysis. And the tool experts can add integrations. Like right now we support Fabricator. And we really think that there's a way to create this central locations for developers to try new analyses. And ShipShape builds directly on an internal project where we're offering program analysis into our code review tools and other tools in Google's internal workflow. So I'm really excited about that. And I see folks from Twitter here and Facebook and some Netflix, some other companies that we're working with to really bring together the development community and all contribute to these tools. So our team is actually working on some other tools in the space that are being driven by other companies here. So we're really excited about that. So cloud computing, what does it mean for us as developers? Well, it means that we should not have to focus on the unnecessary stuff if we don't want to. Now, if you really want to, of course, there's the option to have the level of control that you'd like. But we get to focus on really the code and the product development. And this idea of I don't know, San Francisco is a bunch of rock climbers and climbing. And climbers love steep cliffs. But as developers, I think that we don't like it when we reach a point where there's a steep learning curve, or we've built something and somehow we have to go back and completely rewrite it because it's not going to scale. We should expect cloud services to provide a lot of support for us in that area. And the other idea here is just that ops should be easy, right? We should start to remove some of the operational burden that we have as developers. So finally, I just want to highlight 3 key areas where I feel like the cloud is benefiting software development. The first one is developer velocity, right? So by this combination of shifting operations off to the cloud, we're reclaiming that time back. And by having integrated development environments and a great tool chain, improved debugging and diagnosing tools, we're reclaiming the time that we're spending on things that we shouldn't have to. Scale. So this idea that if you have the next great app idea, you can scale it, right? You can start really small and you can scale it. And cloud services will help you do that. And you get all of the performance benefits of the contributions that are made at the lowest level of the stack. And finally, we have this incredible ecosystem that we all benefit from. And it enables us to iterate very quickly. As developers, we're using a combination of tools and software, and they should work well together. We should be involved in contributing in the community, and I'm really happy that Google is taking steps for us to do that. So at the end of the day, this is all about us, right? It's about making our lives better, and it's about us also continuing to raise the bar on what we expect of cloud services and what we expect of developer tools. So we need a platform that will scale, and we want choices in the platform that we use. And all the scale that I talked about within Google, right, of operating these large-scale systems, I'm really excited that we're bringing that out into the community. So I'm out of time, but I hope you learned a little bit about how I see cloud benefiting software development. And I'm really excited about imagine what our world as developers will look like in 2 years and the improvements that cloud will make to our development process. So thanks a lot for coming, and I hope you enjoy the conference.